In this lesson, we are looking into the final part about chapter 6, which is about projectile. This lesson, compared to the previous 6.3, this is just the algebra version of what you've learned before. So just a quick recap of what you learned before in 6.3. In order to do projectile, first of all, you must remember you are going to use the double suva method, where the first thing is we do a usually ax is always 0 and ay is usually negative 9.8. Okay, unless it's a horizontal projectile, which we went through in 6.1. If it starts shooting upwards, then it's always negative 9.8. And then ux will be u cos theta and uy will be u sine theta to start with. So these two are the fundamentals in the double suva. Then the rest of them we'll have to play it by ear, depends on what we're given in the question. For this question in particular, when we're given the greatest height, then we know the velocity at that point will be, the vertical velocity at that point will be 0. So the Vy or the Uy is 0. Now, we're going to do all of this, but it's just in algebra version. So speak of algebra, there's something you must know before we begin, which is the double angle formula and the identities. So now depends on how the school is done. You might perform it in a different way. You might have learned this, you might have not learned this, but it doesn't matter. Just write down to begin with. So we know sine. So we know sine 2 theta. We know sine 2 theta. So these are what you should know beforehand. So sine 2 theta equal 2 sine theta sine theta. And also we have to know 1 plus n squared theta equals sec squared theta, and 1 plus, I think that's it really, 1 plus n squared equals sec squared. I think that's what we have to know really. And also, of course, tan theta equals sine theta over cos theta. Now, there are more identities you'll learn in pure maths, but these are more the useful ones for this chapter. Right, so as I said before, when the speed is given direction, we first resolve the force into u cos theta, u sine theta, and x and y. That will be included in our double suva. So example, a particle is projected from a point horizontal plane with initial velocity u and an angle alpha. Given the acceleration due to gravity is g, find expression for the flight of time t. So we want to go from point A to point B. Well, double suva x, y, s, u, v, a, t. We know a is 0. Now, ay, we normally put negative 9.8, but because it's algebra, we put negative g. Okay, negative g. U, be u cos alpha and u sine alpha. Right, so these are the fundamental thing for the double suva when just in algebra. Next, we want to find, what else do we find? We want to find a flight of time t. Now, as said, that means we want to find t. We need 3 pieces of information. Now, all unknowns account as information, I guess, but we still need another piece. Well, if you remember what I said before, if you look at A and B, they're on the same horizontal level. It means vertically they have not traveled, because you go up in here, A, and then particle come back down. So we go back to the same horizontal level. Therefore, the vertical displacement is 0. So I'll put in here, okay, because A and B are on the same level horizontally. So we've got enough information, sort of, because it's in algebra. So we look at y. So in the y-axis, also y column, we use s equals ut plus a half at squared. S is 0, u is u sine alpha, t is unknown, plus a half times negative g times t squared. Next, what we have in here is, you'll see a quadratic, t is a variable. So what I'll do is I will bring, actually, what I'll do is I'll factorize the t out. So this is a quadratic, okay? This is a quadratic. and t is the variable. So think about x squared, but instead of you have t squared here, factorize the t out. So you have u sine alpha minus a half g t. Next, in this scenario, what we do is we make t equal 0, or u sine alpha minus a half gt equals 0. If you struggle to understand this, think about this. If I tell you to do this, x squared minus 6x equals 0, how would you solve it? You'll factorize in x, and then x equals 0, or x minus 6 equals 0. That's what we're doing in here. Imagine your x is just a t, right? And then to make t the subject, we'll bring the minus a half gt to right hand side. So u sine alpha equals a half gt. So multiply by 2 to the other side. 2u sine alpha equals gt divided by g. T equals 2u sine alpha over g. That's the answer, right? So all will be in terms of algebra. That's the answer. Part A. Part B, find the range. To find the range is about displacement. Displacement horizontally is about Sx. So part B, they want to find Sx. That's fine. So part B, to find Sx, we need to do super on x column. So S equals ut plus a half at squared. S is unknown. U is u cos alpha. What's t? We just found t in part A, which is 2u sine alpha over g plus, and then a half at squared, half times 0 t squared, doesn't matter. That's t is gone. So if I put everything on the numerator, then S equals 2u squared sine alpha cos alpha over g. So all I've done is, again, I just multiplied this to the top numerator. So 2u times u is u squared sine alpha cos alpha. All right. Next, we know 2 sine alpha cos alpha is the same as sine 2 alpha. So u squared times sine 2 alpha over g. So this bit in here, sine 2 alpha equal to sine alpha plus alpha. So this highlighted part becomes here, and that's the answer. Anything else? Yep, u squared sine 2 alpha equal to g. That's it. Next one. Let's look at it more. A particle is projected from a point with speed u and an angle of elevation alpha moves freely under gravity. When the particle has moved a distance of x, its height of point of projection is y. Show that y equal this equation. So we draw a little diagram if that helps. Actually, this time we're traveling to here. So we know the speed is u, the angle is alpha, and that, okay. So what we know is also with that point we've traveled x, that's y. So needless to say, double super x, y, s, u, v, a, t. So s, again, ax is 0, ay is negative g, ux is u sine, u cos alpha, u sine alpha. Next, what else do we know? Well, we are told when it's travel horizontally x, so the distance is sx is x and sy is y. Okay. They want us to find, they want to show the equation. Now look at this equation. This equation has y equals x in there. That means we want to connect the y and x together. In this two columns, x and y is in the x and y columns separately. So how do we merge them together? Well, there's only one variable, one glue that can put them together, which is the t. So if we make t the subject for both of them, then we can put the two columns together. So t is the only connection between the two columns. So what I'm trying to say is I'm trying to do the super on x and super on y, make t the subject, and then try to replace the other. So simultaneous equation in a way. So x, let's do the x column first. So s equals ut plus a half at squared. So sx is x. Okay, sx is x, u is u cos alpha, t is unknown, plus a half a0. So it doesn't matter whatever is t squared in here. So it doesn't matter. So x equal u cos alpha times t. Now I know I need to substitute t, so I'm going to make t the subject first. So t equals x over u cos alpha, right? Y. For the y, s equals ut plus a half at squared. Sy is y. The u is u sine alpha. T is actually, we have t, don't we? T is here. So I'm going to replace t in here. So t is x over u cos alpha, not squared, not yet, plus a half times a negative g times t squared, x over u cos alpha squared. It looks really complicated, and it is quite complicated. So y equal, now let's do it step by step. The first one, the first fraction in here, you can see we can cancel out the y, cancel out the u, so cancel out the u. Then I'm going to multiply fraction together. So on top with x sine alpha, alpha cos alpha. That's the first fraction. Okay. By the way, just to make you aware, that's highlighted. So that's how we will substitute t. Plus or minus rather, minus a half g, because a half times negative g is negative g, times x over u cos alpha squared. So if I multiply squared inside bracket, it'll be x squared over u squared cos squared alpha. Right, so where are we getting it then? Well, I'm going to continue to simplify a little bit first. So y equals x sine alpha over, well, actually, yeah, cos alpha minus, so if I put a g on top, so it'll be gx squared over, put a u in the denominator, 2u squared cos squared alpha. Right, so what can we do in here? Let's look at the question again. The question, the equation, the question wants us to show has a tan alpha in there. Now let's check it one by one. In the first term, x tan alpha, okay, so x, sine over cos, it can make a tan. Lovely. So we can make a tan alpha in here. So we can, okay, so that's the first step. I can rewrite that as y equals x tan alpha. So that is sorted. Now the question is about second part. Now, if you haven't done the algebra, the trigonometry before, you will find it quite difficult, or you will find it quite new. Now let's look at second term. They have gx squared over 2u squared in a fraction. Do we have that? Gx squared over 2u squared. Yes, we do. But they also have a 1 plus tan squared alpha. So 1 plus tan squared alpha, that means surely this must turn into 1 plus tan squared alpha. So what I'll do is I will separate the two into, so minus gx squared over 2u squared times 1 over cos squared alpha. Now 1 over cos squared is sec squared. So y equals x tan alpha. This is PO2 chapter 6 minus gx squared over 2u squared times sec squared alpha. So sec squared also equals to 1 plus tan squared. So y equals x tan alpha minus gx squared over 2u squared times 1 plus tan squared alpha. That's the answer. Proven. So this part is this one. Right, puppy. Another paragraph. A particle is projected from a point O with horizontal plane with speed 28 meters per second, angle of elevation alpha. Now, if you do realize, actually these two paragraphs are quite similar, but instead they're giving you numbers instead. The particle passes through a point B, which is a horizontal distance of 32 meters from O and a height of 8 meters above the plane. So if you try and match it with the paragraph 1, you will see this is the value of u, that's the value of sx, and that's the value of sy. So what do we want to find? We want to find alpha. Well, they don't ask you to do part A for no reason. So actually, we can substitute that into part A. So part B, when u equals 28, x equals 32, and y equals 8, we can substitute in there. So y is 8. So 8 equals x tan alpha, 32 tan alpha minus gx squared. Now we don't need the algebra anymore, so we'll turn the g into 9.8. 9.8 x squared, 32 squared over 2u squared times 1 plus 10 squared alpha. So what I'll do is I would first of all put this thing in the calculator to simplify into a number. So 8 equals 32 tan alpha minus 6.4, calculator, 1 plus 10 squared alpha. And then I will expand the bracket. So 8 equals 32 tan alpha minus 6.4 minus 6.4 tan squared alpha. Guess what? Quadratic equation. So I'll rearrange it and make it nicely. So 6.4, move everything to the left-hand side. And then minus 32 tan alpha. The minus 6.4 to left-hand side becomes a plus. So 8 plus 6.4 is 14.4 equals 0. Then I can put in a calculator. Let the calculator do the work for me to solve the quadratic equation. So you should get 10 alpha equals a half, or 10 alpha equals 9/2. Now, because the value of alpha must be between 0 and 90 degrees. Well, why? Because when you project that way, the highest you can do is that way, so which is 90 degrees. So that's between 90 and 0, 90 degrees. So what I'm trying to say is no cos diagram. It's only one value. So alpha equals arctan of a half, or arctan of 9/2. And you get alpha equals 27 degrees, or alpha equals 77 degrees. So really, that's this is just the same as the previous one, chapter 6.3, but it's just in the algebra version. You can see students do find it difficult because it's it's algebra really. So the method is the same: double sweep up. Ax is 0, ay is minus g, ux is u cos alpha, uy is u sine alpha. Now, the last one here, the exam question, or you can do as a practice. Now, if you do correctly, you should be able to rewrite part A as that one, so I don't have to give you the answer. For part B, if you got right, your answer should be 10.3 meter per second. So you might want to pause the video and have a go at this question first before listening to my explanation. Now, if you go wrong, then I'm going to go through with you step by step how to work it out. So, example practice. A girl playing volleyball on a horizontal ground and hits the wall, hits the net at 9 meters away. So that's where the ball is strike, and that's the net. Molecular ball try over is 2.4 meters above the ground, so u meter per second by running expression. Okay, so we want to go from the point O to the point over there. Let's call it point A. So part A, from O to A, we're going to do a double sweep out. We know ax is 0, ay is negative g. That's a given. Ux is u cos alpha, and uy is u sine alpha. Okay. Right. Now, Sx we're given from that point O to A horizontally is travel 9 meters. So Sx is 9, but Sy is not 2.4 because from here to there, that point will only travel the difference of 2.4, 1.5, which is 0.9. So Sy is 0.9 because the net height that we gain is 0.9. So this question, I want you to, they want you to connect the two together. So again, you want to use T as a bridge to help you bridge between the two columns of sweep-outs. So S equals ut plus a half at squared. S is 9, u is u cos alpha, t is unknown, and a is 0. So I'm going to leave it out. So I'm going to make t the subject. So t equals 9 over u cos alpha. I'm going to make this equation 1. Next, for y, s equals ut plus a half at squared. S is 0.9, u is u sine alpha, t is unknown, I'll leave it as it is, plus a half times negative g times t squared. Then what I'm going to do is I'm going to substitute equation 1 into this. So 0.9 equals u sine alpha t, which is 9 over u cos alpha minus g over 2 times 9 over u cos alpha squared. So what have I done then? I have replaced the t from what I found in x. Next is all just algebra. In the first fraction, the u and the u cancel out. Sine alpha and cos alpha makes a 10 alpha. So 0.9 equals 9 10 alpha minus, so g over 2, let me do the squared, so 81 over u squared cos squared alpha. Now let me check the question. The word count is not always the same. You have to play it by the question. So the question was 81g over 2u squared cos squared alpha. Have we got that? Yeah, we've got that. We don't have to do any of the shenanigans that we did in last question. 0.9 equals 9 10 alpha minus 81g over 2u squared cos squared alpha. That's it. Okay. Part B, given that alpha equals 30 degrees, find the speed of the ball as it passes over the net. Speed of the ball. Now, speed is not the same as velocity. If you remember from 6.2, the speed is vx squared plus vy squared square root. It's like Pythagoras on the vx and vy. In other words, we want to find vx and vy. Now, we know alpha is 30 degrees. Okay, so what we want to do is we want to use the answer in part A, but if when we substitute alpha in this equation in part A, what are we trying to find? You can tell me. I wouldn't be able to listen. But yes, your answer may be correct. If we substitute alpha, the only variable left is the u, so we're trying to find u in there. So part B, we want to substitute alpha. So when sub alpha equals 30 degrees first. So 0.9 equals 9 10 30 degrees minus 81. G is no longer useful. I'm going to put it as 9.8 over 2u squared times cos squared 30 degrees. Now, you have to be careful when you put cos squared 30 degrees in the calculator. The calculator won't let you do cos squared 30 degrees. What you have to do is you have to put cos 30 and then the square the whole thing. Okay, that's how you work it out. Or you can do cos 30 and then squared. What's next is, I would do 0.9, so 9, 10, 30. So I'll keep the left hand side. 9, 10, 30, put in the calculator is 3 root 3. Minus, the next thing I'm going to do is, I am going to put this in a calculator. So I'm going to put 81 times 9.8 over 2 times cos 30 squared in a calculator. And that will give me 529.2. So minus 529.2 over, so u squared. Or you can use however way you want to. My way is maybe not the most efficient, or maybe it's not the way you want to put it in calculator. Up to you, step by step. Or you can do 81 times 9.8 in the top, and the denominator do 2 times cos 30 squared. However way you want to do it. But ultimately, you should get a 529.2 at the top overall. Next, I'm going to, now the u squared is in the denominator, so I'm going to bring the left hand side and bring 0.9 to the right hand side. So 529.2 over u squared equals 3 root 3 minus 0.9. To make u the subject, I'm going to multiply u squared to the right hand side. So 529.2 equals 3 root 3 minus 0.9 times u squared. Then divide it over. So u squared equals 529.2 over 3 root 3 minus 0.9. And then to make this, to get rid of squared, I can just square root the whole thing. Okay, so square root the whole thing. Now, I don't think I have to say it. You have to put in a calculator, and when you have got the answer, store it in the value, store it in the calculator, because you're going to use it. So u, if you're doing here, you should get u equals 11.1 meter per second. Now, I'm going to store it in A. All right. But that's not what we need. That's not all we need. That is what we need, but that is not all we need because we need Vx and Vy. We found the value of U, so it's time to put in back into each column to find the Vx and Vy. So let's do that. So for the X column, I'm going to do V equals U plus AT. B is V. U is, what's the value of U in the table? U cos alpha. So U is U cos alpha times T plus A T. So V equals 11.1 cos 30. I'm going to leave it like this. Okay. Now remember, this is the value of A. Okay. The 11.1 is the value of A. Next, for the Y column, V equals U plus AT. V equals the value of U in the table is U sine alpha. So U sine alpha, so 11.1 sine 30 plus value of A is negative G times T. Well, where's our T? Do we have a T value? We do. In here. T equals 9 over U cos alpha. So that's equation 1. So T equals 9 over U cos alpha. 9 over U cos alpha times 9 over U cos alpha. Now, if you don't know where this comes from, I'll suggest you use a pencil or use however way, color coding to make sure you understand where this comes from. This comes from the top in here. So all the way there. Next, I'll probably put that in the calculator. So I got a nice number, so I can store it in the calculator. So we plug the whole thing in, you get negative 3.62 meter per second. Well, it's negative. It makes sense because in terms of the velocity going up and down, if going up is positive, now you can see the projection of the ball is coming down. That means vertically the ball is shooting downwards, it's acting downwards, is traveling downwards. So therefore it's negative, and that's fine. So I'm going to store this value in the calculator as B. Next, the speed. Ultimately, the speed is therefore square root of the Vx 11.1 cos 30 degree, whole thing squared, plus my 3.62 squared. So in the calculator, what I'll be typing in calculator is like this. So A bracket, so cos 30 squared plus B squared. That's what I'll put in the calculator. And hopefully you get your 10.3 meter per second. And that's not an easy question. That's why this exam question, that's why it tricked a lot of people. And but I hope you understand step by step how it got done. It's quite messy, but if you know what you're doing, you can sort of follow the flow. All I can do is support you with the method, and you have to apply yourself in there. So again, you start with AX is 0, AY is negative G. UX is U cos alpha, UY is U sine alpha. This time we're given SX and SY, we put it in there, and then we try to do the algebra and find an equation. Part B, we're given alpha is 30 degree, so we put in alpha equals 30 degree. That's nothing more straightforward than this, because you're given one equation and you're given one information, use them together. All right, it's like you're given a lemon by life. What do? You mix lemonade. So anyway, what you do in here is find U. After find U, you realize that's not all we need. Speed is Vx and Vy. So therefore, we're going to do the Vx and Vy, find the U value, and then use the super table to find Vx and Vy. And for some reason, you need a T value. So you look through your pages of working, you found your T value, you found your T equation, sub it in, and then do the Pythagoras. I've run out of breath. And that's the end of chapter 6.